So with these, we want to be able to make a sketch of the graph, thinking about our graph transformations and keeping in mind what we know about our growth factor. So in terms of basic function here, like we mentioned in the last video, for the basic function for graphing, think of it as your function is just the growth factor with your exponent of the variable. Then anything else happening outside of that is a transformation. So what we're going to do is first think about the graph with just the growth factor and the exponent, and then from there interpret the graph transformations. Okay, so with this first one, where I have all this stuff happening on the outside, I'm just going to focus on the base of the exponent and my variable. So for a basic function, I'm just going to focus on 1/4 with the exponent of t. And with that, I'm going to sketch this basic function. So since it's 1/4, I know this will be exponential decay. So it'll be decaying like this, and it's decaying by 1/4. So we'll have the point 0, 1, and then if I move over 1 unit, should have gone down by 1/4, so we'll have a 1/4. And then it would be a 16th, and so on and so forth, and then we'll just be getting close to the x-axis there with the asymptote. Then moving in the opposite direction, it's like it reverses, so in this direction we're dividing by 4. If I go in this, it's like I'm multiplying by 4, so if I'm at -1, well, that flips the fraction, so I'd have 4 over 1, so I have a 4. If I'm at -2, I'd actually be up at 16, which I can't even graph here. So for my basic function, I'm just going to graph, that goes way off there, this, and then approaches the x-axis. Okay, so now I have my basic function, and now I can look at everything else that's happening. So in terms of transformations, I'm multiplying by 2 on the outside, so that means I have a vertical stretch by 2. And then adding 3 on the inside, so that'll be a horizontal shift, and that'll be to the left by 3. So we take care of stretches and compressions first, and then we can shift it. So stretching by 2, I'm just going to take all of these vertical distances and double them. So I have -1, +4, that's going to bump up to 8. 0, 1 will now be 2. Where I was at, what was that, 1/4? And doubling that, it'll be a 1/2. And then an 1/8 would be a 1/4, so on and so forth. So stretching it, we'll get something more like this. And then to end our graph, we're going to shift to the left 3. So I have -1, +8. I'm going to go 1, 2, 3 to the left. Where I'm at 0, 2, 1, 2, 3 to the left. 1, 1/2, 1, 2, 3 to the left. And then it's just going to get close to the x-axis from there. So my graph should look something like this. And approaching the x-axis as best we can and going off to positive infinity. Alright. Okay, our next one. So again, I'm just going to focus on what the basic function is, which is going to be base of 5 and our exponent. So this is going to be exponential growth. So I know I'll be going in this direction. And the growth factor is 5. So I'll start with graphing my basic function. I would be at 1. And then it's growing by multiples of 5. So we'd have 5 to the power of 1 is 5. And then 5 squared is 25, which is going to be way off here. So that's going to go off the page pretty quickly. At -1, that would be 1/5. And then it's just going to be close in to the x-axis along here. And then increases really quickly. There. Alright, so now our reflections. So the negative t, so if we're multiplying by a negative inside the function, so that'll be a reflection over the y-axis. And then we have this -2 on the outside, so that's going to be our vertical shift down 2 units. So I'm going to reflect it, like that. And then we're going to move down 2 units, which means we're going to move the asymptote. We'll move down 2 units. So my asymptote will now be down at y equals -2. And then I'm going to pick up those points. So at -1, +5, that's going to move down 2 units. I was at 0, 1, down 2 units. 1 1/5 as best I can, down 2 units. So our graph is going to look something like this. All right, so visualizing that 5 to the t, and then reflecting over y and shifting down. Again, like I mentioned in that last video, this 5 to the -t, you could also think of this as 1/5 t minus 2. So you'd see that exponential decay like we're seeing at the end here, and then just moving it down 2 units. That would give us the same graph. Okay, for this one, our basic function will be 4 to the x. So this will be exponential growth with a factor of 4. So of 0, 1, 1, 4, 2, 16, which is off the page, 4th, and then that'll get close down there. So basic function looks something like this. And then in terms of transformations, that +3 will have us move to the left 3. And then the -2 will have us move down 2, which will move the asymptote. So we're going to move that asymptote down 2 units. I was going to do that in red, not that it makes a big difference. All right, so there's our asymptote. And I'm going to focus on kind of 3 points here. Not that one, sorry. That -1, 1/4, 0, 1, and 1, 4. So I'm going to move them left 3 down 2. I'm going to go ahead and do this in one step. So I'm going 1, 2, 3, left, and then 1, 2, down. And 1, 2, 3, 1, 2. And I got one more. 1, 2, 3, 1, 2 for 1/4. And then from there, I'll just connect the dots like that. All right, one more here. So we're going to focus on just graphing 1/2 to the power of x. Or if we want to skip a step, okay, let's do this the long way, and then I'll show you a short way, but we can do more with those exponents there if we wanted to. But let's go the long route. 1/2 x, so that's our exponential decay by a factor of 2. So I have 0, 1, 1/2, 4th, 2, 4, 8. So there's our basic function. And now what we'll have in here, so the negative tells us to reflect over the y-axis. And the 2 being multiplied in there is a horizontal stretch or compression. Because it's this whole number of 2, that's going to be our compression by a 1/2. So let's go ahead and reflect first. So I'm just going to move the points to the other side of the y-axis. There. So that we have something like this. And now what I'm going to do is take these horizontal distances, like at 8 we have this horizontal distance of 3, I'm going to cut that in half. And at 4 I have this horizontal distance of 2, cut that in half. At 2 I have this horizontal distance of 1, so a half there. Even at 1, 1/2, that'll now be a half-half, something like that. Alright, so our graph is going to look like this. Okay, where we could have skipped some steps there is this 1/2 to the negative 2x. What I was saying in that last video is how we could think of this as power to a power rule. So what we could do is think of this as 1/2 to the negative 2 to the x power, and just simplify the inside. So we'd flip it, so it'd be 2 squared. So this is the same thing as just graphing 4 to the x, with no transformations outside of that. So what you could see is from our points, so we have 0, 1, we have 1, 4, and if we had 2 on our picture here, it would be up at 16. And then we could see the same effects on the left-hand side of the graph too. So, 2 ways to go about it. It'll make the same graph in the end. It's just sometimes you can do some maneuvers with some exponent rules to simplify the function. And in this case, then you wouldn't have any transformations. It's just a direct graph of 4 to the x.